Hey everybody, just wanted to give you a video recording of the explanation for the balancing equations that we did in class for developing and using a model to determine if the law of conservation of mass is being obeyed or followed. So this was the first equation that was on the presentation today. It was your do now, and I was asking, is this equation following the law of conservation of mass? Why or why not? So what you're going to want to do is, because this is going to prepare you for your asynchronous work today, is draw a model. So here we've got a molecule of Al2O3. There's no big number in front of it, no coefficient, meaning we only have one molecule substance. So I'm going to use green to represent aluminum, so I'm just going to underline it in green. So I'm going to say Al2, and I'm going to use red for oxygen, so red for oxygen, and then oxygen atom, oxygen atom, oxygen atom. It doesn't matter what the structure is as long as you make it all one molecule, all right? Then on the product side, you have two. So notice you have a big number in front of it. You have two of these things. And in this case, it's just an atom of aluminum. So you've got one atom of aluminum, another atom of aluminum. They are not bonded together. Then you have three molecules of O2. So you're going to draw one molecule of O2, two molecules of O2, three molecules of O2. Now, in order to determine if the law of conservation of mass is being obeyed, you count the number of each atom on both sides. So on the reactant side, we've got, if I do my aluminum first, we've got 2 atoms. So I've got 2 green atoms. And on my product side, I have 2 green aluminum atoms. On my reactant side for oxygen, I have 3 oxygen atoms. Okay, notice these numbers are sometimes different than these numbers. These numbers down here are referring to the number of atoms of each of these elements. Okay, but then on this side, I've got 6 atoms of oxygen. These numbers should be the same. I should have 2 and 2, and then whatever this number is, it should be the same. Because these numbers are 3 and I have 6, that means that this equation is not obeying the law of conservation of matter or mass. Okay, it is not following because somehow I got 3 extra oxygen atoms in my products. And that's not possible. According to the law of conservation of mass, matter is neither created nor destroyed. So this equation, as it is written, is not following the law of conservation of mass. Okay, the second equation that we had in our presentation was this one, and it had oxygen and or hydrogen and oxygen coming together to make a new substance, to make water. I'm going to use this light purple color to represent hydrogen. So we have a big capital 2 in front of our H2, which means we have 2 H2s. So here's 1 H2, here's 2 H2. Okay, in your model, if you want to, if you don't have the ability to use colors, you can add the element symbol into the little circles if you wish. I've got 1 O2 molecule, oxygen, oxygen. I don't care, again, I don't care if the models are 100% correct. I just care if you're drawing accurate according to what's written here, because technically oxygen has a double bond between it, but that's not important at this point, okay? And then you have 2, a big capital 2 in front of this entire thing. Okay, so 2 of these molecules. So that means I've got 1 oxygen molecule in each of these one oxygen atom in front of each of these molecules. And I use this little light purple color for the hydrogens. So there's my 2 hydrogens on that molecule. Here's my 2 hydrogens on this molecule. So now I have 2 H2Os. Okay, so I'm gonna color code this. I got purple for my hydrogen. I used red for my oxygen. Now I need to count them up. I've got 2 oxygens on my reactants side. and I've got 2 oxygens on my product side, 1, 2, okay? Then I count up my hydrogen atoms, 1, 2, 3, 4, 4 hydrogen atoms, and 1, 2, 3, 4 hydrogen atoms. This equation is following the law of conservation of mass. So I'm going to say yes, it is following the law of conservation of mass. You would need to use evidence. In your assignment today for asynchronous, you have to use evidence, and your evidence would be that these numbers are the same, okay? 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. Okay, so there's the first 2 equations for the lesson today. And here are the next 2 equations. So the next one we had was 3H2 plus N2 yielding 2 NH3. Going to use this light purple color again for my H's. I have 3 H2s, so there's 1, 2, 3. And for nitrogen, capital N, I'm going to use this blue. Here is my N2. Then I have 2 NH3. So again, that 2 refers to all this stuff right here. So then we have 2 of these molecules, which includes 1 nitrogen. So each molecule has 1 nitrogen. I'm going to draw those first. And then 3 hydrogens. Each one has 3 hydrogens. Then you count the number of atoms of each element on both sides of the reaction. So reactants side, I've got 1, 2, 3, 4, 5, 6 hydrogens, so 6 H's. And on this side, I've got 1, 2, 3, 4, 5, 6 H's also, 6 H's. On the reactant side, I have 2 N's. On the product side, I've got 1, 2 N's. I still have 2 N's, even though they're not connected to each other, they're separate, even though there's no subscript here after the N, but there is here. Notice the numbers equal out. I've got 6, 6, 2, 2. That means that yes, this is obeying the law of conservation of mass. Next, we had this equation, which was a little bit different. We had 2 things on both sides. We had 2 reactants making 2 products. So I'm going to use black for carbon. So this is 1 carbon and 4 hydrogens. So then I had 1, 2, 3, 4 hydrogens. And then I had 2 O2 molecules. So here's 1 O2 molecule, 2 O2 molecules. Then on this side, I had a CO2, which is a carbon atom in the middle. And I have oxygen over here and oxygen over here. And then we had water, which is 1 oxygen and 2 hydrogens. Whoops. Oopsies. Where's my thing? There it is. Hydrogen, hydrogen. Actually, now that I realize this, I'm looking at my equation on my other screen, and I realize there's supposed to be a 2 there, which means I need to draw another oxygen molecule, or excuse me, water molecule. I need to draw another water molecule. There we go. This is the equation that was written in our presentation today. So now I can look at it and I can count my atoms, okay? So I have 1 carbon on this side, I have 1 carbon on this side. Oxygens, 1, 2, 3, 4 oxygens over here, 4 O's. And I've got 1, 2, 3, 4 O's over here, 4 O's. Hydrogens, 1, 2, 3, 4 on the reactant side, 4 H's, and 1, 2, 3, 4 H's on our product side, 4 H's. So again, this is following the law of conservation of mass. So yes, Your evidence would be that the atoms are the same on the reactant side and the product side. All right, we did one more equation in class, but I feel this video has gone on long enough. If you need help, always reach out and ask. I hope this helps, whether you were in class or not. Good luck on your assignment, folks, and have a great day.